A quadratic equation is any equation in the form ax squared plus bx plus c equals 0, where a is not 0. If it were 0, we'd have a linear equation instead. The graph of a quadratic is always a parabola, that distinctive U-shaped curve. The quadratic formula finds the roots of any quadratic equation. The coefficients a, b, and c come directly from the standard form. The plus or minus symbol means we can have two solutions. This formula works for all quadratic equations. The discriminant, b squared minus 4ac, tells us about the nature of the roots. If it's positive, we have two real roots. If it's 0, we have one repeated real root. And if it's negative, we have two complex conjugate roots. Time for a challenge problem. Solve 2x squared plus 7x minus 15 equals 0. With a equals 2, b equals 7, and c equals negative 15, we get x equals negative 7 plus, or minus the square root of 49 plus 120, all over 4. Can you find the solutions? Engineers use quadratic equations for bridge design optimization. They calculate maximum load capacity and stress distributions. The parabolic shape provides optimal strength-to-weight ratios for suspension bridges and arch structures. In finance, we use quadratic equations for profit maximization. The equation Px equals dash 2x superscript 2 plus 100x, 500 models profit based on price. Finding the vertex gives us the price that maximizes profit using our quadratic techniques. Completing the square is the method behind the formula. We transform x superscript 2 plus bx plus c equals 0 into a, x, h superscript 2 plus k equals 0 form. This geometric approach shows why the formula works and provides insight into the parabola structure. The graphical method involves plotting the parabola and finding x-intercepts. This visual approach is useful for estimation and verification. Modern calculators and software can plot these curves instantly for quick solutions. When the discriminant is negative, solutions are complex numbers. We write x equals negative b plus or minus I times the square root of the absolute value of b squared minus 4ac, all over 2a. For example, x superscript 2 plus 4 is equal to 0 gives x equals plus or minus 2i. The discriminant analysis shows how b superscript 2 for ac affects root nature. Positive discriminants give two real roots. Zero discriminants give one repeated real root. Negative discriminants give two complex conjugate roots. This classification is crucial for understanding solutions. Let's recap our key takeaways. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. It solves any quadratic equation in standard form. The discriminant tells us whether we'll have real or complex roots. And remember to always verify your solutions. Thanks for learning with AI.